another edition of What's Happening. I'm Elliot Margolis. I'm here with my co-host George Binns, and this is part 2 of the climate change global warming debate between Kevin O'Reilly and Frank Ballini. When we left you in the last show, we were talking about, is the sea level rising and why? And Kevin and Frank were having a little to do about that. So let's go back to Kevin and Frank and let them talk about their charts and why Frank doesn't believe Kevin's chart. So Frank, you start.
I'm going to share my screen if that's okay.
That's fine.
Are you seeing that? Battery, New York?
Yep.
Okay. These 3 graphs represent 3 very good data stations with verified and validated NOAA data. I never saw the data that Kevin posted for these charts, these types of charts, NOAA sea level charts. And I worked with them. The NRC, when we licensed nuclear power plants, the United States told us to use these charts without any impact or any revision for global warming. So I believe those guys. That was 5 or 6 years ago, and I do not believe that anything has changed. The straight line relationship shown here is indicative of the fact that CO2 has had no impact whatsoever on global temperatures. And if you look back even further and put this in context, a little bit different y-axis here, but this is the straight line relationship that we're looking at here on the other graphs. And this is prior to that. Something happened in 1860 that changed this kind of a horizontal trend into this kind of a vertical trend. Now, here is the section of time where 85% of man-made CO2 was put into the atmosphere post-1945. There's absolutely no difference between what happened during the Lincoln administration and what happened during the recent Trump administration. I don't know where that data came from, and it makes no sense to me. I will agree that CO2 is rising, and there's no doubt about it. But CO2 makes no difference what concentration CO2 is at, because I'm going to stop share, and I'm going to try and get to another screen share here if I can. Here we go, and screen share again, and go to well, let's go to this one. Let's take a look at the results and how they've been fudged from models. These are model results from 2000 to 2015, and they're predictions for changes in temperature as a result of CO2 in the atmosphere. You can see where they're going here. It's pretty clear that there were gross overestimates at the beginning in the up as high as the 5-degree range into the future. And now we're working down in the 1 and 2 degree range. And I believe that we're even probably a little bit lower than that here in 2021. These kinds of models, I don't know if you've ever worked with mathematical models, but I have, and I was actually expert in a groundwater model and in a radiation dose model. You can get any results you want depending on what your inputs are, and that's exactly what these guys are doing. There is no way to say that these guys knew what the heck they were doing back at the beginning of this century, and it spurs me with no confidence that they know what they're doing now. Go ahead, take it away.
Okay, Frank. Kevin, you're up.
Can't hear you, Kevin, you're muted.
Kevin, you're muted.
Sorry. Okay.
All right, there you go.
No,
Yeah.
what was all
Okay,
that
I'm relaxed
hand-waving?
now. Okay.
Sounded
so,
great, but
So let's see, I do turn it. Okay, so if we go back to the graph, and you said that, I guess I'll just go back for a minute because you brought up three different things. These are the people at NOAA. For you to ask the question, where did you get it from? I just went on, typed in NOAA and got it on the NOAA website. And that's what intrigued me to see why they were saying in general, sea level is accelerating versus a straight line. So that's how I got to that. And it's very straightforward. All you got to do, Frank, is go on NOAA website and you'll see it yourself. Okay, Greenland and Antarctica are losing mass, and they're losing it at an accelerated rate. And these are, again, leading scientists. So Greenland ice loss, this is from the other day from the NASA website. And you can see Greenland is going down, down, down. So they have satellites to do this sort of thing. Antarctica is complicated because East Antarctica, as you can see here, is, let's see if I can move that, it is actually gaining ice and not, it's taking water away. But the other areas are big ice losses and adding to sea level. So again, these are the leading scientists. Antarctica, again, leading scientists. And how does that work? So if you look at this chart, accumulation zone and ablation zone. So it's accumulating snow and then it's losing snow down towards the edges. And some people have talked about a P38 being, dug up and it was in 300 feet of snow. Well, it's a darn good thing it is, because if it ever, it's in this area of accumulation zone, if it ever doesn't do that, we are all in trouble. So overall, Antarctica and Greenland have been losing ice. Now, Frank mentioned the models. How much time, do I have enough time to go into models?
Yeah, you've got another 2.5 minutes.
Okay. Okay, so these are models. One question is, how accurate are they? And you can see this line, the red is the observation and the black is the models, and they're pretty close. Some of them are above and some are below. The average is sometimes above and sometimes below. And they use thousands and thousands of measurement stations to gather this information. And again, these are leading scientists. This guy is at the NASA Goddard Institute. And again, this is another one where the predicted line is the black and the observed lines are the observations, and they're pretty close. But Frank did this graph, and this one shows something completely different. It shows that the red line, the models, are way higher than the observations. And that really made me wonder, like, why are these graphs so different? And I looked at the title and I thought, wait a minute, what is it really measuring? So I went back to the original one at the University of Alabama at Huntsville, and this is what it said. That's the actual original graph, tropical. And tropical, as you know, is not global. Second, it's mid-tropospheric. That is 25,000 feet above the ground, where it's cooler. So what's going on here? Who did this graph, and are they deliberately trying to fool us? Well, the next iteration of it was they changed the word to global. They kept the 25,000 feet, that's good, but they had 4 balloon data sets and 3 satellite. So other scientists said, can we look at your data sets so we can peer review them? And they said, no. They did not share their data sets. They're not peer reviewed. One of the people that uses this is Patrick Michaels, who appears a lot on Fox News. And he gets, as you see there, 40% of his funding from oil companies. And oil companies want to stop renewable energy. they'll lose money. In the 1990s, he worked for tobacco companies to question whether smoking causes lung cancer. But even he says, we have known that increasing atmospheric carbon dioxide would eventually result in warming. This is the graph Frank just showed you. So I looked at this guy, Scafetti. He worked with a guy, West, on this. He also refused to share his data with other scientists. He presents at the Heartland Institute, which is by oil companies. He predicted there'd be imminent cooling in 2009, which there wasn't. And he's criticized by other scholars that they designed their tests to prove a hypothesis rather than the other way around. And
I've got to stop you there.
Okay, he said human activities cause global warming.
Okay, my next question, and this one, Kevin, you start. We'll give you 5 minutes. Is it possible to reverse global warming if it is man-made or if it is natural?
Okay, give me a second here. Okay, go back here, share. Okay, so if we go back to Frank's graph, again, wait, didn't I already do this?
Yeah.
Yeah.
Okay, wait a minute. Sorry.
You have all my sympathy. It's a very complicated subject.
Thanks, Frank.
Yeah.
Okay, I'm going to go back to the models part because I already did the natural one in previous, if that's okay. So I think I got to this point. No, we already did this. Okay, yeah, let's finish. Well, I think I did that too.
Let's just get down to the question. Can we really reverse global warming?
Again, I don't think the question is whether it's natural or if
Natural, man-made, and can it be reversed?
Right. Okay. So of course, if it's man-made, it can be reversed, and the way to do that is to stop putting in CO2 in the atmosphere. If we need to slow that down. And as I've shown, that the models are accurate, and the model that Frank put up is very suspicious. So the models are predicting that things are going to get worse, and yes, we can do it. If you're eating a lot of cake, you just stop eating the cake. We can change this. So I think I will take my time to do one of these other questions. Frank brought up about a trace element. It's only a trace element. So if I go to, well, let's do it this way. 52. Okay, so Frank, you said that it's just a trace element. Well, if you had a ham sandwich and I said there's poop in it, but only a trace element, I'm pretty sure you wouldn't eat it. Or if you had arsenic, just a little bit in your drink, you wouldn't do it. But more relevant to us.
Not analogous.
Well, how about glass? How about glass?
Not analogous.
Frank, just let me talk. The amount of glass in a greenhouse is a very small percentage. The other thing about that is that oxygen and nitrogen have no relevance to heat going in and out. You could say, well, it's a very small amount, a trace element compared to the entire universe too, but it doesn't have anything to do with it. And I get no funding from the sandwich, glass, or water industries. So it's important to think about that. Frank had mentioned water vapor, but temperature increase water vapor. Water vapor multiplies the effect, as you can see on the chart, of other greenhouse gases. So it actually could be one way or the other. Water vapor stays in the atmosphere for hours or days, and CO2 stays in for decades or centuries. So water vapor is a greenhouse gas, but the other greenhouse gases are increasing it. And Richard Lindzen, who's one of the more famous critics, when he argued that that you got to watch for this, he was saying there'd be less cloud cover because it reflects back to the Earth. This was called the iris effect, and it was invalidated by 4 other people. So let me say that again. Lindzen, who's a critic, was arguing that there'd be less cloud cover with more CO2, and other people then invalidated that. Okay, how much time do I have left? Probably nothing.
1 minute.
A minute?
1
Oh,
minute.
I feel so good. Trace elements. Oh, source reliability. Okay, we can't do these in any depth. But you brought up about the sources. And I'll start on this. I don't know how far I'll get. So you had said in your talk something like you have to deal in graduate level physics. So I went to the American Physical Society to see what they said. And it turns out they said human influences increasingly dominate the global climate warming. But you are also a geologist. So I went to the American Geological Society of America that says emissions of carbon dioxide and other gases is a primary source of warming. But I didn't stop there. I went to the American Geophysical Union and Geosciences and American Chemistry, Meteorological. So all these people say, peer-reviewed, this is what they do for a living. These are the top experts. You yourself said you have to understand this at a graduate level. These people are at it. And the question I have is, what about the critics? Do I have any time left?
Nope, you're
No.
done.
Okay.
You're done. Frank, you're on.
Let me share a screen here. I'm going to jump right into some science here because some good studies have been done by a fellow by the name of Nikolov and his partner Zeller, published in 2017. There's the link. And information is also available at a kind of a lower level, easier to understand on the internet. You can find this guy, Robert Holmes, who goes by the moniker 1000 Frawley on YouTube. And he takes what is a simple ideal gas equation where the density of the gas is equal to, whoops, sorry about that, is equal to the pressure times the mass of the whole atmosphere divided by a gas constant, R, and that gives you the temperature. So we can change this equation around and solve for temperature and get it this way. He took this information for these planetary bodies in our solar system, and you'll notice how the lines are pretty much the same general shape. And what this graph is, this is a graph of degrees Kelvin, and the temperature we're sitting at now is probably about 290 degrees Kelvin. 0 on Kelvin is absolute 0, so there's no Brownian movement left. So it's a very different scale than centigrade or Fahrenheit. And here we have pressure of the atmosphere, and of course that depends on how much atmosphere there is. Now on Venus, there's a heck of a lot of atmosphere. It's mostly carbon dioxide, 96%. Now I would submit to you, Kevin, if we went to 96% carbon dioxide, what would you expect the atmosphere, what would you expect the temperature of the atmosphere to be? Based on global warming and climate change business, we would all expect to be evaporated. Earth has a very different constituents that comprise their atmosphere: nitrogen, oxygen, thank goodness, because we can breathe it, and a tiny little bit of carbon dioxide. It's not even enough to spice it. Jupiter and Saturn have similar but different than Earth or Venus. It's mostly a hydrogen and helium atmosphere, and that's because they have big gravitational fields, and they held in a lot more of these light elements which escape from Earth and Venus, the smaller planets. And then Titan, same deal, except it has no CO2, it has methane. Now, we would expect very radical differences. The only different curve here is Venus. And that's because It's close to the sun. It picks up a lot more heat. And Earth is not terribly different than the rest of the planets. This is what drives temperature on the planets. And you can look at this y-axis and say, this would be the temperature as we come down through the atmosphere. So obviously we're warmer at the bottom of the atmosphere than we are at the top of the atmosphere because heat escapes pretty readily. Here are the results of his calculations. And there are two bars here. One is measurements made by approximation by astronomers or flybys or satellites or whatever we happen to throw at these various planets. The point here is that the actual temperatures measured in some way are exactly the same as the calculated temperatures based on the ideal gas law. What this tells me is that it makes absolutely no difference what the composition of the atmosphere is. The temperature of a planet results from the amount of atmosphere and the density of the gases that comprise the atmosphere. This is what Nikolov's paper says, essentially the same thing, and he plots it up a little bit more elegantly than Holmes does. But if you want to go to these guys and you want to get the straight skinny on how it works, how global warming, if you will, works, that's the place to go.
Okay, so that wraps up the questions. Now, what I would like you gentlemen to do, and since, let's see, the last question was Kevin, you started for us, so we'll let Frank start. Just
Summary and conclusions.
Yeah, it's time for a
give
summary.
give a summary of what you've discussed, and see what you can do to convince the public of your point of view.
That I will do in just a second. First thing I want to do is show you a summary of good, realistic science sources that you can use, and I hope you can jot this stuff down or come back to it on the YouTube channel and get these links. These are places where you get good science. So there's the bottom one there. Conclusions. Sea level data completely contradicts the anthropogenic global warming CO2 hypothesis. Geohistory of climate, that graph that we continue to look at, shows clear natural cycles of massive climate variations prior to the evolution of man and over the past million years, clearly uninfluenced by anything man did. Simple analysis of the universal gas law shows how planetary bodies in our solar system have temperatures independent of the atmospheric gas composition, and atmospheric CO2 content is irrelevant. Global warming and climate change studies are driven by funding from politically motivated individuals. And Kevin, you kept appealing to authority on those things without really citing anybody or citing any studies. I can give you citations from here to the end of next week on this stuff. But these folks whose data you're looking at are politically motivated. We're talking political science here, not real science. Milankovitch cycles, which is key to understand, drive weather and appear to drive climate. Solar inputs to the magnetic field of the Earth. I guess I didn't finish this last one here, but we'll end with this one. Solar inputs to the magnetic field of the Earth appear to be driving weather. This is a new science that has popped up. Both the Earth and the sun have magnetic fields. They join together, and as the sun releases energy into space, the Earth's magnetic fields are affected. The magnetic fields, in turn, produce electric fields, which influence our weather, and it's becoming pretty clear that it's influencing climate. The website on YouTube, the posters on YouTube are called Suspicious observers with a 0 rather than a O. And you can go to suspicious observers on YouTube, and you will find that information. That is my summary. Thank you.
Okay, thank you. Kevin, you're on.
Okay. Frank, okay, you stopped sharing. Thanks. Okay, how much time do I have?
3 minutes.
What? Oh my goodness. Okay. Frank, you know that Nikolof's theory has been thoroughly debunked, this whole atmospheric thing.
By those who have a
I have never
financial
interrupted
investment, a significant financial investment in this.
you. Okay.
That's the debunking.
Let's go back to the slide I had up on the sources on the other side. So what are the sources? Frank put up these. He just put 3 of them up again. So Tony Heller has a master's degree in electrical engineering. John Robeson has a PhD in American history, and Joanne Nova, who he cited, as a bachelor's in microbiology. The other 3 do have it in this field, so that's fine, but they all say CO2 causes warming. They're critics, but they still do it. These people are funded by oil companies. They participate in the Heartland Institute, and Tony Heller gets his own thing. So Tony Heller has been touted by Frank. This is on his website. These are statements by him that Antifa attacked the Capitol on January 6th. Anti-Trump terrorists are at the Capitol. The latest from criminals at NPR.
I didn't think we were doing politics here.
Because the reliability of the sources. You have cited these sources as being reliable.
Yeah, so I use Heller because Heller breaks down for the common man.
I did not interrupt you at any point when you were.
Oh, I'm sorry you didn't.
Okay, so he said that Joe Biden is working with the scientists for China. In November, he said that the election was a fraud. 2014, he had all these things to say. So one of the things that I think people should think about is on the left-hand side are the people saying there's global warming are experts in the science field. There's many, many of them. They subject their stuff to peer review. They don't have a reason to store it. Now, Frank has said, well, the political, these guys would make more money by going over to the oil companies than they do as professors in universities. They go with science and not conspiracies, and there's agreement on warming. On the other side, we have many people that aren't qualified. There aren't that many of them. They refuse to share their data sometimes. They're funded by oil companies. If you want to talk about people who have a reason to distort, they have much more of a reason. And one of them, at least, is a conspiracy peddler. And some of them, even then, agree with that there is some warming.
Kevin, we've run to the end of the time.
Let's ask the people in South Texas what they think, since we're going into politics.
Guys, we're finished.
I wish you'd brought that up earlier.
Thank you, gentlemen. Ladies and gentlemen, stay tuned, and we'll probably get some more shows on. This is not an easy subject, as you can imagine, and it's very important, as has been pointed out, which way we go. It's disaster, financially or society-wise. And thanks for watching, and we'll be back.